am Peter Navende, a senior lecturer in the Department of Information Systems under the School of Computing and Informatics Technology in the College of Computing and Information Sciences, Makerere University. Our innovation is a software tool for point-of-care training for prostate cancer. The innovation has 3 components. The first component is an e-learning system that has electronic learning resources that students can access about prostate cancer diagnosis and treatment. The second component implements the practical aspect of the training, where students get to diagnose and generate reports that will be assessed against expert reports. The third component has an automatic diagnostic capability. It automatically diagnoses images, MRI images associated with the prostate. So the problem the software tool is helping to solve is, in the first place, through each of the components. For the first component, it helps to provide a structured curriculum that is currently non-existent. The second solution is that it helps to decongest the point-of-care training environment. In so doing, it frees the instructor to be more productive in their diagnosis and treatment tasks, and also it helps to reduce the risk of infections around the point-of-care training environment. The RIF fund has supported a number of costs associated with the development of the innovation. First and foremost is the ethical clearance process. The funds really helped support different parts of that process, including the IRB and the National Council. Then obviously the development of the innovation itself took a lot of funds or costs, or required funding different people, including radiologists, IT experts, and computer scientists. The radiologists were funded for data collection, especially the images and their processing. The IT people were funded for the development of the tool, the software interfaces. And then the computer science people were funded for the development of the models for automatic diagnosis from the MRI images. And finally, the tool and its different resources needed to be validated and evaluated, needed participants. So the funds helped facilitate the evaluation or fund some of the participants. This innovation to be impactful in 3 ways. One is in form of access. The software tool can be easily accessed by anybody, and therefore it can accommodate large numbers of trainees. Secondly, the innovation, because it can be accessed remotely and does not require the expert instructor like in the physical case, it means that the physical instructor is relieved of the training load, and therefore they can concentrate more on the diagnosis and treatment work. Thirdly, the tool implements automated diagnostics and a structured reporting template. This should lead to efficient diagnosis, and therefore more cases, significantly more cases, can be diagnosed. Our next steps will be for 2 components of this innovation. The first component is the gamified learning system. There we plan to continue developing more modules around prostate cancer. The ones we've developed so far are limited. They are for piloting in this case. Then secondly, we plan to continuously improve the models in the third component. That is where the automated diagnosis takes place based on MRI images. So there we shall try to continuously improve the models, either by using recent improved machine learning methods or exposing the diagnostic models to more training MRI images. Lastly, we have focused in this project on prostate cancer. The innovation we've developed so far is for prostate cancer. In future, we plan to develop similar innovations for other types of cancers. I would like to take this opportunity to thank the Makerere University Research and Innovations Fund for funding this project. We promise to continue working on its innovation to make it more effective so that we can try to save many lives of Ugandan men.